Hey, this is Jesse Tula for BatchFrame.com, and in this tutorial I'm going to be taking you through how to create a gravity and bouncing animation. And if I play through this, you can see that we're creating an effect where this text, in this case, drops and bounces on this ground. And that's what I'll be showing you how to create. So to start out, I have a clip of a tennis ball bouncing on a table. And if I scrub through, you can see how this bouncing happens in real life. You can see that it starts up high, and every bounce gets slightly faster and slightly lower. And that's the look we're going to be mimicking in After Effects. So I'm not going to be tracking this and attaching it to a layer, although you could do that. We're going to be creating this using expressions in After Effects. But before I start, let me just show you. I took this same clip and I put it into a new composition and animated it along the x-axis. Now, if we think of this x-axis as time instead of the position, we can graph the bounce of this ball. And I've already done that. So if I turn this layer on, you can see the bounce of the ball. You can see the type of curve it is, and then it hits a point and goes completely the other direction. And you can see that the heights get smaller as we go along, and the time between the bounces gets gradually smaller as well. So this is the graph that we're going to be using as a reference during the rest of this tutorial. So let's get started. What we want to do is create a new composition. And to start out, I'm just going to create a new null object with a slider. And I'm just going to be using this to show you the expressions and what they do that we're going to be using for this effect. Now you should know that there is some basic math and geometry and trigonometry that comes into play here, but it's pretty simple, and with the explanation you should be able to get it fairly easily. So to start out, let's just Alt-click on the slider stopwatch, and that will bring up the expression for this property. Now to start out, I'm going to type in time. Now this is sort of the base of our expression, and what time does is sets a value equal to the composition's time. So to show you this, I'll create a new text, and we'll just increase the font size, bring down the source text, and we'll set the source text equal to this slider. And so up here in the composition window, you can now see that as time increases, it's increasing the value. And using time is what makes our whole expression possible, because if it wasn't for a constantly changing value, our expression would only create a static animation, so there would be no animation. So using the time function is the base of our entire expression. Now the next thing we want to do is create the start of our curve. Now right away we're not going to have that bouncing curve that I showed you from the video, but we will get there eventually. So to start out, I'm going to type in a math function, and more specifically the cosine function. So to do that, this is case sensitive. I'm going to type capital M math dot cos for cosine, and then in parentheses we'll type time. And now we have our expression. And now to show you what this is doing, I'm going to open the graph editor, this icon up here, and we have to turn on the graph for this expression. And so now you can see the graph we created. And this is just a standard cosine graph. So this cosine graph is what we're going to use and manipulate to create our bounce. Now you might be wondering why we're not using the sine graph. Now I can show you why. I'll duplicate this, and we'll change the expression down here, go back to our normal view, we'll change this to sine. And if we graph both graphs, you can see that they're slightly offset. Now I'm just going to show you just the sine graph, and you can see that our sine graph, if I zoom in here, is starting from the origin. Now that won't work for us because we want our bounce to start from its highest point and work its way down. So if we were using the sine graph, our object would start at its lowest point and bounce up to its highest and then slowly go down from there. We don't want that to happen, obviously. We want to start from way up, and that's why we use the cosine graph, because the cosine graph, you can see, starts from its peak point. And that's what we want. So once again, I'll show you these side by side. The cosine graph starts from up here, whereas the sine graph starts from the origin. So we can delete this. Oops. Just the one. And we have our cosine graph once again. And now if we zoom in here, you can see we start at the highest point, go all the way down, and then back up. And you can see that our graph repeats at around 6.5, a little less than 6.5 seconds. Now the reason for this is that in After Effects, the curve is based on radians, not degrees. So this would be 360 degrees, which is also equal to 2 radians, which is 2 pi. And if you know that pi is 3.14, 2 pi is 6.28, which is right where this graph repeats. So in order for us to be able to talk about this curve in terms of seconds, instead of in terms of radians, we have to add a little bit to our expression. So we'll open that back up. And we are going to multiply time by 2 pi. So put in times 2 times, and for pi in After Effects, there's actually a JavaScript function, which is just capital M math dot pi, which is pi, both capitals. And if we click off and go back to our graph editor, you can see that our cosine graph has become skinnier, but if we scrub to the beginning and look at where our curve now repeats, you can see that our peaks happen every second. And that'll make it easier later on when we want to control how frequent the bounces are going to be. Now the major problem with our graph right now is that it doesn't look like a bounce path. You can see that if we take the center point, or the origin of our graph, we actually have values that go below 0, which wouldn't work for us. We need our values to always stay above 0, and after each peak we need a hard corner and the graph to go back up again. Now this is actually fairly simple to do. What we're going to do is take the absolute value of all of our values. What absolute value does is makes any number positive. If it's negative, it's going to be positive. If it's already positive, it's going to stay positive. So -1 would become 1. And what that's going to do is flip all of the graph that takes place below the origin. And that will create our bounce look. So what we're going to do is go back out of our graph editor, and we're going to wrap this entire function in our absolute value function. So we're going to type in once again math dot, and this is ABS for absolute value. And we'll add our opening and closing parentheses. And if we go into our graph editor now, you can see what we've created. We have only positive values. You can see the 0 or origin is down here. And after each peak, we have a sharp corner, and the graph goes up once again. So that right there is going to create our bounce effect. But let's go back and look at the graph that I made from our video clip. You can see that the graph that we have, each hump is the same height. However, in our video, the graph gets exponentially smaller. And notice that it does get exponentially smaller. So we are going to have to use an exponential function to mimic this look. So let's go back into our comp that we're working on. And I'm going to create a new null object to show you the exponential function. And we can turn off the graph for this one. And we'll just use this. And I'm going to go and delete the function we have so far. And we'll start out with our basic exponential function that uses time as its variable. So math.exp, and inside the parentheses we'll put time. And back into our graph editor, you can see that our exponential curve is slowly going up. It is creating the curve we want, but we want our value to slowly go down. So the easy way to fix this is just to make our time negative. So negative time, go back into our graph editor, and now you can see we have that exponential decay that we were looking for. So if we go back to our curve, you can see that exponential decay here, which is similar to what we've got right here. So what we need to do now is combine the exponential decay with our cosine function that we created. But before we do that, I want to look at where this decay ends. So I'm going to zoom out here. And if we watch this value over here, and we scrub through, you can see that right about at 5 seconds or so, it finally reaches 0. Now the problem with an exponential function is that it never truly does reach 0. If we look into this, you can actually see it. It does say it's 0, but there really is a value here. There's always going to be a value. It never hits 0. And this is a problem because if we use this as our decay, our effect will never stop bouncing. It's always going to have a little bit of an up and down wiggle until it becomes non-apparent. But this won't work for us. So we'll need to keep that in mind. Now another thing I want to do is be able to change the decay based on seconds and not just a number. So to do this, we're going to have to find where our value reaches 0. And as I said before, it was right around 5 seconds. So if I zoom in here, you can see that the curve is not hitting the ground or in the 5 second range, but it is at 0, and that's what we're going to worry about right now. So if I scrub back, and I'm just going to go through frame by frame until it hits 0. So you can see right there, 0. And we're at 5 seconds, 8 frames, which is 5.3 seconds if we have 24 frames per second. So 5.3 is our number there. And I'm going to go back into our expression, and I'm going to do negative time times 5.3. And we'll go back to our graph editor. We'll zoom out, and actually we'll zoom back in, but we'll zoom in towards the beginning of the comp. And now if we go to the end of the graph to where this hits 0, if we go through frame by frame, you can see that we now hit 0 at 1 second. So later on, when we create our controls for this expression, we'll be able to use a number in terms of seconds to tell After Effects when we want the decay to end. So we can now use this new function in combination with our cosine function to create a cosine function that has a decay. So what we'll do is we'll copy our exponential function and multiply it by our cosine function. And now we can delete the second null. So if we take a look at our graph, you can see that something's happened to it. We have one little point, but then after the second hump, it just kind of goes flat. Now the reason for this is that the combination of our decay and our frequency have caused our graph to decay too quickly. So we can fix this by either making our decay take longer or by increasing our frequency, and that's what I'm going to do. So we're just going to multiply this by a number, and I'll just choose 5. So 5 times time times 2 times pi. And now if we go into our graph editor, you can see that now we have that decaying cosine graph. And if we look at this and then we look at this, you can see how similar they are. So that's what we've been trying to create. So now what we want to do is take what we have here and apply it to a text layer or whatever layer you're using. And we'll add some controls to make it more user-friendly, and we'll add a little bit of a script, because if we zoom in here, as I said before that the exponential graph never actually reaches 0, you can see that as I scrub through, there's always going to be some sort, and it's kind of invisible here, but you can see that our bouncing lasts for much longer than we want it to. So we'll create an expression to fix that. So let's get started. We'll just stay in the same composition, and I'll create a new layer. And this will just be our floor, if you want to call it that. Oops. We'll scale this down in Y. And we want this to be 100 in X, not 0. And so we just have this fake floor. And we'll put our text on top of that. And we'll scale this text down a little bit. And we'll just put it on our floor. Now, so you know, wherever you put your object is where the floor is going to be. So you don't want to put it at the top, you want to put it at the lowest point you want your object to be. Whether it's text or a solid, whatever it wants to be, put it at the lowest point. So now we can go into our null and we can copy this expression. Control C, go into our expression, hit P to bring up the position. Alt click the stopwatch and paste. Now we're going to get an error when I click off. After expression warning must be a dimension of 2, not 1. Now the reason for this is that our expression is only creating one parameter. And we need both an X and a Y for our position to work. But the only position that needs to be animated is the Y-axis. So what I'll do is set this whole equation equal to Y. So capital Y equals. And at the end of a line, in case you're not too familiar with JavaScript, we need to put a semicolon. And we'll hit enter. And we're going to take the position, so the current position, and to get that you just type in position, minus 0, because we're not changing the X, comma, and our Y. And both of these Y's must either both be lowercase or both be uppercase. It is case sensitive. And you could have named this anything you want. You could name this Y position. You could name this anything you want as long as it's the same here as it is down here. And we'll put another semicolon down here. So now if we scrub through, you probably can't even see it on the screen recording, but we have a tiny bit of movement. Now the reason that you can barely see it is because right now our function is creating a number between 0 and 1, which means that the most it's ever moving up is 1 pixel. So obviously that's not going to work for us. So what we want to do is multiply this entire function by a larger number, which we're going to be calling the amplitude. So we'll do 800, which is just a random number. You can make it whatever you want. And we'll multiply it by our entire expression. So I'll wrap it with parentheses. And now you can see that our text starts way up high. And as we scrub through, our text drops down and bounces. However, you can see that it's already done bouncing pretty much by the time we get to 1 second. So what we need to do is increase our decay time. So what we'll do is after our multiplied by 5.3, we'll divide by the number of seconds we want our decay or our bounce to last. So let's say I want this bounce to last for 5 seconds. I'll divide by 5. And now you can see that our bounce stays larger. And if we zoom out, you can see it keeps on bouncing until we get to 5 seconds, at which point it's just kind of wiggling at the bottom, which we will fix later on. So now it's just a matter of playing with our amplitude, our frequency, and our decay rate to create a bounce that looks good. And you can always go back into our graph editor to see what your graph looks like. So obviously we have way too many bounces in this amount of time. So to change that, we can go back into our function and we can decrease our frequency. So let's say I change it back to 2. Let's see how that looks in the graph editor. So that makes a little bit more sense, and you would have to render it and play it through to really see how this is going to look. So it still might be a little bit too frequent. I'll probably change that down to something like 1.5. We'll go back into our expression. 1.5. Open back up our graph editor. Look at it. Looks pretty good. Render it. Play through. Alright, so that's not bad. But as you can see, every time I want to change this, I have to go back into our expression editor and change the values there. What I want to do is create some sliders so that we can control our expression just through our Effect Controls panel. So I'm going to create 3 sliders, and we're just going to go to Effect, Expression Controls, Slider. And I'll duplicate this 2 times. And we'll call one Amplitude, one Frequency, and one Decay. And then, here's where we're going to get a little bit tricky if you're not used to JavaScript with our expressions. So we're going to create some variables. We'll call one amp for amplitude. And we're going to set this equal to this first slider. And to do that, I can just choose the pick whip and drag it up to our slider. So our amplitude is equal to our first slider. We'll create another value called for frequency, so FREQ for frequency, and we'll pick whip our second slider. And make sure you're ending these lines with our semicolons so we know that there's an ending to the line. And the last one, decay. And as with the y variable, you can name these whatever you'd like. Just make sure that you know the case and you continue to use the same case throughout your entire expression. So we'll just put a space there to separate them. And what we want to do now is replace our different values with these variables. Now I'm not going to do that right away because all of these values are currently set to 0, and because over here we have a divide by our decay, if we leave this as 0, we're going to get an error that says divide by 0, whatever. So what we're going to do is we're going to change all our values to 1 just to have some sort of value set. And now we're going to go through and we're going to replace our values within this expression. So we'll change the 800, which is our amplitude, to just AMP. The 1.5 to our frequency. And this 5 over here to decay. And once I click off, you can see our bounce goes away, but that's because all these values are now set to 1. So we'll change them back to what we had. Amplitude to 800, frequency to 1.5, and decay to 5. And yes, you could have done that before instead of setting it each to 1. But we can see now that these sliders are working, and if we scrub through, we once again have that same bouncing effect. Okay, so our expression is pretty much complete, except that we have right now our decay set to 5 seconds. But if we look, our title still has some movement after that 5 seconds is up. So what we're going to do is move this expression around and change some things to make it so that after the 5 seconds that we set, our animation stops completely. So there's going to be a little bit of moving around here. First of all, we're going to create another variable called decay final. And we're going to put our expression for decay onto here. I'm going to cut this and paste it over here. And so now our decay final can go in where this expression just came from. So decay final. So what we have now is exactly the same as what we had before I made that change. You can see our animation still happening just as it was. All I did was turn the last part of our expression and made it equal to a variable, and then we replaced that part of the expression with the variable. So it's all just rearranging right now. But the reason for this is because after the 5 seconds, we want this value to stay 0. So to do that, we're going to create an if-then statement. So we'll type in if, and this should be lowercase if, parentheses, if the decay, which is our value that was set up here. So if our decay value is less than the time, so once the time is 6 seconds, our decay is less than that. So this statement will become true. So once our time becomes greater than the decay we set, we want this function or this expression to stop working. So we'll type an opening bracket, hit enter twice, and type a closing bracket. So if the decay is less than the time, we want our decay final to be equal to 0. So what that's going to do is once our time is greater than 5 seconds, the second half of this expression right here, where the decay final is going to be equal 0. And because we're multiplying by 0, the expression is going to end up equaling 0, so there will be no animation. So let's look at this. We still have our bounce, and we'll zoom out here. We still have our bounce. That gets smaller and smaller. But once we hit that 5-second point, even if I zoom in all the way here, you can see 5 seconds, there's still a little bit of bounce. After 5, the animation is stopped completely. Now the issue with this can be seen if we go into our graph editor. If we zoom way in here, now it happened to work out pretty well for this, but if our value was set to something like let's just say 5.2 seconds, you can see that in the middle of a curve, it suddenly drops down to 0. So in this case, we would have a very abrupt stop to our animation. So when you're creating your animation, make sure that the time you set it to is right about at the lowest point in our graph. And you can see that it does sort of go up before it stops, but it shouldn't be a problem because it's such a small space. So let's zoom back out and zoom out here and render this. And so you can see we have our bounce. Now one more thing, if we go back to our original curve, is you can see that over time the bounces happen more often. And here's where another benefit to our expression controls comes into place. You can see right now we have a frequency of 1.5. We're going to use that value and we're going to keyframe it so that over time our frequency increases. So over our 5-second period, we're going to go from a frequency of 1.5, and we'll go to 5 seconds, to 2. So it's not much, but it is more frequent. And if we render this, I know you can't see it too well, but it does create a little bit more realistic of a bounce. Now having this bounce last for 5 seconds with the height it's at is kind of pushing what looks realistic, but I hope that you can see what we're going for. And if I change the decay down to something like, I don't know, 2.5 seconds, and edit our frequency values, we can create a little bit more realistic of a bounce. And even that, we just created by changing 2.5, creates a pretty nice looking bounce. And you can use this, even though right here in our example we only have a single dimension. You can use this in 3D space, you can use this on other objects, whatever you want inside After Effects. and create a nice gravity bouncing effect. So I hope you learned something from this tutorial. I hope you'll look into expressions more and see what they can do for you. There's a lot you can do with expressions, a lot of complex things that would take hours to animate otherwise. And for more information on expressions, you can go to Dan Ebert's website at motionscript.com, where he takes you through all the different amazing things you can do with expressions and the different types of animations that you can create easily with very simple expressions. So you should check that out if you get a chance. But that's it for this tutorial. I hope you learned something, I hope you enjoyed it, and I hope that you can use this in your motion graphics projects. So, thanks a lot for watching. Once again, this is Jesse Toole for batchframe.com and creativecow.net. If you have any questions about this tutorial, please feel free to leave a comment or contact me through my site, batchframe.com. Thanks a lot. I'll see you next time.